Quadratic functions have the following general formula, where function of x equals to ax squared plus bx plus c, where a, b and c can be any real number. Here are some examples of quadratic functions. If a changes, the curve bends differently, and even flips depending on the sign. If b changes, the y-intercept stays the same. And if c changes, the graph moves vertically along the y-axis. Note that all of them have the same distinctive curve shape. The most important identity is the presence of x squared. If a equals to 0, the equation becomes a straight line instead of a curve, which is not a quadratic function. However, if b equals to 0 or c equals to 0, it is still a quadratic function. Most of the time, we are tasked to find the x-intercepts of the quadratic curve, which are the values of x that equate the function of x with 0. These values of x are called the roots. One special thing about the roots is that multiplying the equation with a factor, or equivalently dividing it, has no effect on the roots. We will use this observation later. Finding the roots is known as solving the quadratic equation. So how do we solve equations like these? The quadratic equation can always be represented in this form. You can see why this is correct in our video Quadratics Are Just Latin Squares in the description below. From here, it is easy to solve for the roots of the equation. Every technique of solving a quadratic equation is based on this observation. There are two techniques we will go through today. The first method is called completing the square. The trick of this technique is to make x appear only once in the equation. On the left hand side, we have x squared plus bx, where x exists in two terms, but we can manipulate it in such a way so that x only appears once on the right hand side. To understand this better, you can try going backwards from the final result. For example, let's say we need to solve this equation. First, we make a equals to 1 by dividing all the terms with a. This doesn't affect the roots like previously shown. Then, we try to make x the subject by bringing the term without x to the right. After that, we can use our trick so that x appears only once. Now, we can proceed to solve for x by performing some algebra. Remember, when attempting to find the square root of a number, you need to have solutions for both the positive and negative versions of the square root. As you can see, the roots for the equation are x equals to 2 and x equals to negative 5. You can verify these answers by plugging them back into the original equation, where as you can see, it will give you 0, which means your roots are correct. Again, the trick of this technique is to make x appear only once. This may look complicated, but after a few practice runs, this will feel familiar and obvious. For completeness, here we show that any constants for a, b and c can be converted into this simple form for any advanced viewers out there. The second method that can be used to get the roots directly with only one step, through using the quadratic formula. You can also find a derivation of this formula through a previous video. From the previous example, we can just plug in the numbers into the formula, which will then give you the roots of the equation. We don't recommend this approach since it doesn't let you appreciate the beauty of quadratics. Another way to represent a quadratic function is this. Here, the alpha and beta are the roots of the function. To see why this is true, you can watch our previous video, but here we provide a few visual examples. Do note that the roots of the function are always equal to the values inside of the brackets. In the case of finding the roots, function of x is equal to 0. With some algebra, we can convert this equation into this tidy form. Notice that the second term is the sum of the roots and the third term is a product of the roots. We can do the same thing for the general form. by dividing the equation with a. By comparing the two equations, we can see that the sum of the roots is negative b over a, while the product of the roots is c over a. Sum of the roots can be abbreviated as SOR, while the product of the roots can be abbreviated as POR. Most importantly, you can now rebuild the quadratic equation when given the SOR or POR. Do notice the minus sign before the SOR. For example, let's think of two roots, 3 and 7, and hide them away. Instead, we will tell you the SOR and POR and ask you to rebuild it. You can very easily rebuild the quadratic equation by putting these values in. Here, you can also verify that the roots are indeed the hidden 3 and 7. Remember, we can only recreate quadratic equations with this, not a quadratic function. To conclude, quadratic functions have the following general formula. You can solve quadratic functions with two techniques, completing the square and using the quadratic formula. The sum of the roots and product of the roots can be used to rebuild the quadratic equation easily. Thanks for watching. By the way, we have a Discord server with the link in the description. Do join if you love to discuss mathematics inside or outside the Malaysian syllabus. See you in the next video.